All right, so we just looked at a little bit of calculations based on temperature. So we're going to go a little bit further into heat energy and energy in general. So first thing we're looking at is exothermic energy. This is heat energy. Um, it gives off, it releases. Think of it like a fire. You can feel the fire. It's releasing the energy. Then you have endothermic. We're going to be hearing these terms later. Endothermic. It absorbs the heat. It's absorbing the energy. Think of it like you put your hand down on a cold table. It feels cold because it's sucking the heat from your hand. If you sit on a cold rock, your butt starts to get numb. It starts to feel cold because it's sucking the heat energy out of your butt. All right, so here's the thing. Matter has mass and volume, right? And the big thing about it is density right here, table T, last page. You have the formula. What I want you to do in the white part, I want you to write this, a triangle, just like this with a T in the middle. You have D, M, V. Think of it like you're driving, DMV. It goes up, DMV. And the reason I say that is because density is a unit of mass per volume. How much there is per how much space it takes up. Okay? Why do I do this? Because this is great. It saves your brain from trying to do algebra while trying to figure out things. It's a quick, simple thing. So density is mass over volume. Well, what if I want volume? Mass over density. What if I want mass? Density times volume. All right, it's a simple, easy, real quick fix if you go and use this for any density problem. With density, you can find it labeled unit-wise as grams per centimeters cubed or milliliters. We'll get to why it's centimeters cubed in a second. Actually, you know what? Let's do it right now. So if you have a box and you are measuring the volume of a box, think back to math. Volume equals length times width times height. And what do we typically measure in here in chemistry? We measure by centimeters. So centimeter times centimeter times centimeter equals centimeters cubed. Just like in math, where you go x times x times x. All you do is x, add those up, and make the exponent. Same thing goes with the centimeters, all right? Let's get some calculations in. So we have a chemist was trying to figure out the main component of a cleaning solution. They figured out the mass of the substance and they found the volume of that substance. It was 19.625 grams for 25 milliliters. And they want to figure out what the compound is likely to be. So first thing we got to figure out, because it gives us a bunch of densities, maybe I can figure out density to figure out what it is. All right, let's figure out the density. So you're going to put your formula like this, D equals this, and you're going to calculate out. Now you can notice, because we're doing division, we got to figure out your sig figs. It's looking like I want about 4. Okay, so how are we going to do this? Well, 19.625 divided by 25, you get that answer, right? 0.785. All right, so it's 0.785 grams per milliliter. Does it match up with one of these at the bottom, one of these substances? Yes, it does. There you go. It's that isopropyl alcohol. Let's do a little bit more. Let's do that volume. All right. A student measures the dimensions and mass of a block of aluminum. It gives you the dimension. This times this times this. Maybe we got to figure out the volume based off that. Mass, it gives you the mass. What is the experimental density? All right. Volume equals length times width times height. We're going to have 1.20 cm times 3.78 cm times 1.49 cm. I know it's going to be cm cubed, so I'm just going to punch it into my calculator. 1.2 times 3.78 times 1.49. I think that's wrong. Yeah, 1.2 times 3.78 times 1.49. I got 6.758. I'm going to go to 3 sig figs. 6.76 centimeters cubed. That's my volume. My density is 17.65, so I'm going to get my density of 17.629 grams over 6.76 centimeters cubed. I'm going to punch it in just like this. 17.629 divided by 6.76 gives me a 2.61. So 2.61, and it's going to be grams per centimeters cubed. All right, we're doing some percent error. Oh no. Using the true density, find the percent error. True density of an element can be found on table S. So you're going to look down here in the names. You're going to look for aluminum. It's number 13, followed across to density, 2.70 grams per centimeters cubed. Okay, that's my actual. I've got my measured. Measured minus actual over actual times 100 gives you percent error. So punching in, plugging in the numbers, 2.61 minus 2.70 over 2.70 times 100 equals. So the first thing I'm going to do, number one, do the top. Then I'm going to do the absolute value, then divide it by the bottom. So the top, 2.61 minus 2.7 gives me a negative 0.09. So I'm going to take the positive 0.09 over 270 gives me 0.03333333. I'm going to times that by 100. Keeping with 3 sig figs, because that's what I started with, should give you a 3.33% error. Okay? All right. So we're going to start looking at some phases and how it can be shown to you. All right, gases, we've already seen that. You remember they're kind of far apart. Solids are in a structure all together. Liquids are kind of like loose, but somewhat together at the same time. This is just a description of what it is. You know that solids have definite shape and volume. Liquids have definite volume, no definite shape. That means they fit whatever container they are put into. Gas, no definite volume. Yeah, looking around, there's like no blocks of gas falling on my head. Or shape. They fill up as much as possible. The forces involved in keeping things together for these phases. Solids are really, 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 really strong, with liquids being intermediate, because remember, they're fluid, they're moving, so they have to have some movement going on. And then gases are super weak because they're everywhere, as far apart as possible, which we get to next. Packing, how close are they? Solids are super close. They're on top of each other. They're linked. They're geometric shapes. Liquids, they're close. We've seen that in the last lab, but they're kind of random. They're kind of close, but they're kind of random. And you can see that right here. And gas, as far apart as possible and totally random. Doesn't matter. type of motion they have. So solids, because they're so close together, all they can do is vibrate. That's all they can do. Now, because liquids have some motion, like some movement, they're a little bit farther apart, they have like a vibration and rotation. So it can spin and vibrate at the same time. Gas, they spin, they vibrate, and they bounce off the walls. That's what translational means. So they spin, they vibrate, and they bounce off the walls and each other. One way we can look at different phases is the heating or cooling curve, depending on which way the line's going. So as time goes on and temperature increases, it switches from a solid to a liquid to a gas. And you'll notice there's this big flat when it's changing from a solid to a liquid, from a liquid to a gas. We'll go on that when we get to entropy. Here's a phase change diagram. So as pressure increases, it becomes a solid. As temperature increases, it becomes a gas. And at some point, they become all three. We'll get that in a different lesson. All right, so let's look at some properties. We already have seen physical and chemical. Physical properties are stuff that you can describe the substance. Color, shape, taste, smell, all of those are physical. Chemical, it's how it reacts with something. Does it react? Does it not react? How is it reacting? An example is flammability. Is it flammable? Yes or no? That's a chemical property. Now we get to these words intensive and extensive. So extensive, it is dependent on the size. For example, mass. This mass will have I'll have much more mass here because there's more of it than if I was to pull it in part and have two smaller sections. They would both weigh less or mass less. So the mass definitely is dependent on size, which means it's extensive, outside how big it is, okay? Intensive, that's inside something. It's not as big it's not showy on the outside. It's what's inside that matters. That's like density. It doesn't matter how big or how small it is. It's still going to have the same density all throughout. All right? Okay, so what's physical, chemical, extensive, intensive? So melting point, that's physical. And it is not dependent on anything else. So it is extensive. It doesn't matter how big or small it is, it's still going to melt at the same point. Volume. Volume is physical. You can measure that. It's not a change, it's not a reaction. Volume is not dependent on the size, because think of liquids. You can have different volumes. Okay, so volume, how big, like how much of stuff is in there, that is physical, and it is based on outside stuff. Like you could have a change in volume all over the place. I'm going to want to say that is extensive. It doesn't matter what's inside, like what it's made of, it can change in volume. Reactivity, that is definitely chemical, and that's inside. That's what it's made out of tells you if it's going to be reactive. All right, so changes, physical, change phase, form, alter the, does not alter the properties. Original matter can be reformed. Chemical, there's a reaction. It changes what it was into something totally new. We talked about that. And so iron rusting, is that chemical or physical? Water dissolving, or water dissolving salt. Wood burning, frying an egg, recycling aluminum, ice melting, baking bread, breaking glass. Okay, so homework. Make sure you do Travelog 2, finishing up the green worksheet. If you have any questions, let me know. Hope you guys have a great day.